This is the question where we have to solve this differential equation by using the Laplace transform. So we are using the Laplace transform to solve this differential equation. So we start with applying the Laplace transform. I'm going to use LT for Laplace transform on both sides of the differential equation. Okay, so this is our differential equation. Now its second order differential equation, it is provided with two initial conditions. These are initial conditions. Okay, so when we apply Laplace transform, it will give us Laplace transform of x double dash minus Laplace transform of 4x dash plus Laplace transform of 4x is equal to Laplace transform of 0. Okay, now we will use the rules here. So let's say this is 1, this is 2, this is 3 and this is 4. So we have used the linearity property to distribute it. So let's start with the first term. Laplace of x double dash. So we know the formula that if we denote the Laplace transform of x by capital X of s, then we have Laplace of x dash, the first derivative as s x of s minus the value of x at 0, and the Laplace of x double dash as s square x of s minus s x of 0 minus x dash of 0. Okay, so let's use this formula here. So this gives us s square capital X of s minus s x of 0 minus x dash of 0. Now the value of x of 0 and x dash of 0 is available from the question. Substitute it here. S square x of s minus s into the value of x of 0 is 0. X dash of 0 is 3. So this cancels to become 0. So we end up with x square x of s minus 3. This is Laplace of x double dash. Okay. Now we'll find the second term. Laplace of 4x dash. So as 4 is a constant, we can take it outside. We can write 4 times Laplace of x dash. Now which is equal to 4 times Laplace of x dash means we are going to make use of this rule. So as it is having two terms, so we should write a bracket which shows that 4 is multiplied with both terms. Okay, now the value of x of 0 from the question. So it is 4 s times x of s minus 0. So this gives you 4 s of x of s. This is Laplace of 4x dash, the value of second term. Now third term. It is Laplace of 4x. Again we can take 4 outside as a scalar. Laplace of x. Now here it is without derivative. Without derivative means we have to use this term. So it is nothing but 4x of s. Okay, this is Laplace of 4x. And what about Laplace of 0? Laplace of 0. 0 is a constant, so it says 0 upon s, which is nothing but 0. So once we have the value of all these 4 terms, this implies Laplace of 0 is 0. Once we have the value of all these 4 terms, we substitute it back over here in this equation. So what it gave you? First term we have s square x of s minus 3, and then in between we have minus, we use this value 4s x of s, then we have plus, we write 4 x of s equal to 0. Okay, so what we did, since 3 is the term which is not having x of s, we move it to the other side. So it is minus 3, it become plus 3. Now xs is common in all three terms, we take it out as a common factor. So here we left with s square, then minus, here we left with 4s, and then plus 4. This is equal to 3. Now as we are looking for the value of x of s, this is 3 over s square minus 4s plus 4. So we can write it as 3 over s minus 2 to the power 2. Okay, now what x of s stands for? It stands for Laplace of x. So it means Laplace transform of x is 3 over s minus 2 and its power 2. Now when we have to solve a differential equation, it means we are looking for the value of x. So to get the value of x, what we have to do? We have to take inverse Laplace transform of both sides. So this gives you Laplace inverse of 3 over s minus 2 to the power 2, and which is equal to, I'll say that this is equal to 3t e power 2t. Now how do we get it? See, let's consider this term separately. Laplace inverse of 3 over s minus 2 to the power 2. So s minus 2 to the power 2. So it means we are going to work on this rule, 1 over s plus s to the power n plus 1, which gives you t to the power n over n factorial, right? So we are going to convert it as 3 over s square, where s is replaced by s minus 2. This gives you e power 2t. This gives you 3t. Hence, the answer is 3t e power 2t. We make use of second shifting property. And what was it? That property says that if Laplace inverse of f of s is denoted by f of t, then the Laplace inverse of fs plus a, which we can also write as Laplace inverse of fs, s goes to s plus a, s is approaching to s plus a, this is f of t times e to the power minus at. So we have to work on this principle to get the solution.